Hi everyone. Good day. My name is Isaac Eskin from mathleague. I welcome you to today's session. Now, in today's session, we have a question that we want to find a solution. Now, the problem says a real number x between 0 and 0.5 inclusive is chosen uniformly at random. Let capital E be the expected value of the first digit to the right of the decimal point in the decimal representation of x squared. Compute the greatest integer less than or equal to 100 times what? E. So now what we know is that from the question, we know that x belongs to the closed interval 0, then 0.5. Now if this is so, then this implies that x squared will also belong to 0, then 0.25. Because if you square 0, you get 0. If you square 0.5, you get 0.25. Now, the question says that we should compute the expected value. We should find the expected value of the first digit to the right of the decimal point in the decimal representation of x squared. Now, so if what I'm going to do is I want to divide this interval into some sub-intervals, right? So if x squared belongs to this sub-interval 0, so it's a half interval, right? Now it is closed at 0 but open at 0.1. Then the first digit after the decimal point, is actually what? 0. And you can see it here. The first digit after the decimal point, because here we have 0.00 because there's nothing after the 0. So the first digit after the decimal point is 0 here. Now if x squared belongs to this sub-interval, so 0.1, 0.2. Sorry, so 0.2. All right, let me clear this and rewrite it well. So if x squared is between this interval, this half interval, then we know that the first digit after the decimal point from here, this is to the right? So the first digit after the decimal point is 1. We can see that it is 1. Now, if x squared belongs to this sub-interval now 0.2 to 0.25, then the first digit after the decimal point here, you can see that it is 2. So we have this. Now, you can also see that for x squared in this interval, in this sub-interval, for x squared in this sub-interval, it implies that x belongs to this sub-interval 0, then the root of 0.1. And of course, this is the same as 0, so it is a closed path. So 0, then 0.3162. Right. I've just written the root of 0.1 in decimals, and that's what we have here. Then for x squared, also in this sub-interval, we have 0.1 from 0.1. Of course, this means that 0.2 is not included, right? It is closed here at 0.1 but opened at 0.2. So 0.2 is not included. This also implies that x is between the square root of 0.1 then the square root of 0.2. And of course, in decimals, we are going to have 0.3162 and then 0.4472. Now, lastly, if x squared is in this interval 0.2 then 0.25, it also implies that x is in the interval root of 0.2 then root of 0.25. And of course, if I put this in decimals, we have 0.4472, then we have 0.5. So from this, I'm going to compute the expected value, right? The expected value E. Now notice that the first digit, right, after the decimal point of this interval, that is x squared belonging to this interval, was 0. And then I want to multiply this by the length, the difference between these intervals. So I'm going to have 0 multiplying 0.3162 minus 0 plus. Now when I consider the second sub-interval where x squared is in 0.1 to 0.2, the first digit after the decimal point is 1. So I have 1 multiplying. Now the length here, it is 0.4472 minus 0.3162. plus, now the first digit after the decimal point for x squared in this sub-interval, we can see that that is 2. So I'll multiply 2 by this length here. So we have 0.5 minus 0.4472. Of course, I would divide everything here by the total length, right? Because each sub-interval has equal weight. So dividing by the total length will help us to normalize the expected value, right? Because don't forget that the interval is a continuous interval from 0 to 0.5 inclusive, right? So the total length is 0.5. So if you do this calculation, you realize that here we are going to have 0 plus, of course, 0.4472 minus 0.3162 will give us 0.131. And 0.131 times 1 will just be 0.131 plus, now 0.5 minus 0.4472 will give us 0.525, and the multiplying that by 2 will result in 0.105. Then we divide all this by 0.5. Of course, this is equal to, now the numerator is going to give us 0.236 over 0.5, and then this will give us 0.472. Now, mind you, the question says we should compute the greatest integer less than or equal to 100e, right? So here, we need the floor of 100e, and we have just computed e to be 0.472. So this is going to be equal to the floor of 100 times 0.472, right? And of course, this will be equal to the floor of 47.2. And don't forget, we are just interested in the integer part of this. And of course, this is going to be 47. So this becomes the answer to this problem. So the greatest integer less than or equal to 100e is 47. All right, so I hope you understood and enjoyed this session. Thank you very much for having me here. Goodbye.
Hey, this is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.